All right, so looking at the first one, if you would, Abigail, will you go over it for us, please, ma'am? Will you read it and then tell us what you would do to find the answer?
Okay, so first I have to go. It says analyze the pattern below. How many total squares does the next pattern have? And then, wait, Mr. Martin, what else did you say you wanted me to do?
I just want you to tell me what term four would be. Like what pattern are you noticing from term one to term three that's going to allow you to figure out what term four would be?
I think term 4 would have 9 squares.
Okay.
Because I'm noticing that since it started off as 3, then like on term 2 it put the 3 squares, but then it added 2,
Mm-hmm.
and it did the exact I don't know how to explain it, but that's just it added 2.
Okay. So who can add on to what Abigail's saying?
That all they're doing is just adding 2 more.
Okay. And so each time they just add two more. And so that means, just like Abigail said, we'd have a total of 9. So if you were to draw this, should look something similar to this. Hopefully y'all's looks a little better. I'm drawing with a mouse. Does that look right, Abigail? All right. So I actually looked at it a little differently than y'all, but I'm going to wait to tell y'all what I saw whenever we get to number 2. So, looking at this, Destiny, will you read number 2?
Which equation would allow you to determine the term number that can be made with exactly 25 squares?
All right. So, did you come up with an equation? Or do you know how you could figure that out? Can anybody help her out? Nobody's real sure. So, thinking about what Abigail and I believe that was Haley we're talking about, we're saying that there's 2 more that are appearing each time. And so, what I looked at was that term 1 had 1 for each side plus this one at the top. Term 2 had 2 for each side plus the one at the top. Term 3 had 3 for each side plus one at the top. So what I came up with was this would be x times 2, because there's 2 sides, plus 1. And I would set it equal to the number of squares. So you could also have wrote like 2x plus 1 equals 25. Now, y'all said it adds 2 every time from where you were. So if somebody can change this and make it work for them too, that's perfectly fine too. Did anybody have something similar to what I had? Or have anything different? Or did you just leave this one blank? Just need somebody to talk to me.
It's blank.
Okay. So let's make some sense out of it. We know that it equals 25. And so if we have 2x plus 1 equals 25, if we take that 1 away, we'll know what's on each side. So if we take it away, we're left with what?
0.
Yep. And then we got 2x equals, what's 25 minus 1?
24.
All right. So if both sides together are 24, how could we figure out what one side would be?
Divide.
So we would divide by 2 on each side. And so we find out that x is equal to what?
12.
12. So pattern number 12.
I was looking at it too hard.
Say that again, Najela.
Like when I had to solve for the x's, I was looking at it too hard.
That's okay. After we do it a couple times, it'll all make sense, I bet.
I just took the longer way and I just added them.
That works. Perfect. Did you get the same answer?
Yes, sir. I got 12.
Perfect. That's great. So you kind of like made a chart or a table, kind of, and just kept adding up. That works. Did anybody do it different than Haley or me? All right. Well, let's take a look at number 4. Eli, read number 4 and answer it for us, please.
Which situations can be represented by the equation 3x plus 15 equals 288? Select all that apply.
All right. What you thinking?
So A says that Nate buys a phone that costs $288. He is able to put down $15 and then pay the remaining balance in 3 equal payments. What is X the amount of one payment?
Would that work?
No, it wouldn't work.
All right, let's look at it. We got 3x plus 15 equals 288. And if we're going to solve this, the first thing that we got to do is get 3x by itself, right?
Yeah.
So to get it by itself, what do I need to do with this 15 here so that 3x is alone?
You need to divide it.
I can't divide it just yet because this says plus 15. So how do I make this 15 become 0? We do something with its opposite. What do we do?
Subtract.
Yeah, we can either add the opposite or subtract. So when we subtract 15, we get 0. And if we're thinking about this like the balance scale model, if we do it to one side, we have to do it to the other because of the subtraction property of equality. So we're left with 3x equals 273. Now to solve, we would do what Eli said. He said we would divide by 3. And so when we do that, we would get x is equal to 91. Because 3 divided by 3 is 1. 27 divided by 3 is 9. So looking at the first one, Nate buys a phone that costs $288. He's able to put $15 down. So that means he paid $15. So he only owes $273 now. And then he has 3 equal payments. Would that work? Yes, it's going to work because that means he only pays $91 3 times. Let's look at the next one. Nate upgrades his phone. He makes 3 equal payments of $288. So that's like $288 plus $288 plus $288. That's going to be a lot more than $91, isn't it? For 3 payment? Yeah, so that's not going to work. C says Nate bought his 3 children identical phones and chargers. He spent a total of $288. If each charger was 15, what is X? Well, this means that we have to do...
No, that means 15 times X.
Yeah, so, or like 15 times 3 and then 3 times X. So it's a lot. It's not going to be right. All right, let's look at what Nate says the 4th time. He bought his 3 children 3 identical phones and chargers. He spent a total of $288. If each charger is $5, what is X, the cost of the phone? So if each charger is $5 and he only has 3 kids, how much money is that? Isn't 5? Yeah, it's $15. So if we subtracted $15 from $288, and then we broke it up into 3 For 3 children, would it still be $91?
Yes.
Yep, so that one works. And the last one says he bought his 3 children identical phones totaling $288. He used a coupon for $15 off. And it says, what is X, the discounted price of one phone? Well, to find the price of one phone, you'd have to divide it by 3 people. So would that still be $91? Yes, it would. That's right. So we would get A, D, and E for that one. All right, let's see what Fred does. Would you read that one for us, Roy Kia?
Fred rents a goat cart for the rental price of $6 per hour, plus a deposit of $10. Fred only has $30. Which inequality can he use to find how many hours he can rent the goat cart?
All right, so it says he only has $30. So Roy Kia, does that mean he can spend over $30? If he only has $30?
No.
No. So that means he can only spend $30 or what? Could he spend less than $30?
Yes.
Yeah. So how could we say $30 or less? What inequality sign would that be?
The less than or equal to.
Correct. So we're looking for one that looks like this. So C's out. All right, so we got A, B, and D. That would possibly work. Now we know that it says $6 per hour. So how can I show $6 per hour? Do we know how many hours?
No.
No. So what do we do for something that we don't know? What do we use?
X.
An X. So we got 6X, and then it says plus a deposit of $10. How do I show that?
Plus 10.
Plus 10.
And we said that it was less than or equal to how much money?
30.
30.
All right, so which one up here looks like that?
D.
D. Does anybody have a question about that one? All right, let's keep moving. Let's see what old Wilma has to say. Emma, read about Wilma.
Wilma wants to go to the beach. She rents a surfboard and a frisbee for 3 hours each. The surfboard costs $20 per hour, and she spends $66 total. How much per hour does the frisbee cost?
All right, so how would you solve this?
I would multiply 20 times 3 because that's the number of hours, and then subtract that from 66,
Okay.
and then divide by 3.
So how much is the frisbee going to cost per hour?
$2.
Perfect. All right. This right here is called mathematical reasoning. You did a great job. Did anybody do it algebraically? I don't figure most people do, but I'm going to show you how to do it algebraically. It's basically exactly the same. So we do 3 times 20 plus, I say F because we don't know what the frisbee cost. And we set it equal to 66. Then we do exactly what Emma said. We're going to multiply both of these, so we get 60 plus 3F equals 66. And then so we subtract by 60. And so we're left with 3F equals 6. And then to solve, we divide by 3. And so we find out that the frisbee cost $2. Everybody see how that works? What property is this right here? Starts with a D.
Distributive.
That's right, the distributive property. Has anybody got a question? All right, well, let's look at this next one. So the next one, what does it say, Haley? Number 7.
Find the solution to the inequality. Negative 2x minus 6 is greater than or equal to 7.
All right, so we got negative 2x minus 6 is greater than or equal to 7. So Haley, what are we going to do to solve this? What's the first thing that we need to do? Who can help her out? What do we need to get by itself first?
X.
Yeah, we want to try to get x alone. So to get negative 2x by itself, what do I need to do to negative 6 so that it becomes 0? Because I want to make a 0 pair. So negative 6 plus what number would be 0?
6.
Correct. So we make a 0 pair. And so we're going to use the addition property of equality, because whatever we do to one side, we're going to do to the other. And so we're left with negative 2x is greater than or equal to 13. Now, how do I solve for x? Since I know that negative 2x is greater than or equal to 13, how would I find out what 1x is equal to? I mean, greater than or equal to?
Divide.
That's right. We're going to divide by negative 2. Now, who remembers what happens if we divide by a negative on an inequality? What happens to that inequality sign?
Positive.
Well, it flips. It changes direction. All right. So kind of, sort of. All right. So x is going to be less than or equal to 13 divided by negative 2. So somebody put that in your calculator real quick if you got your phone out. What is 13 divided by?
6.5.
All right. And since we divided by a negative, is it going to be positive or negative?
Negative.
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 Good. So we would have put this and negative 6.5. All right, number 8 says 2.5x plus 15 equals 4. What are we going to do to solve that, Joel? Joel can't hear me. Somebody else help him out. What could we do to solve 2.5x plus 15 equals 4? What's the first step? We've done it in the last 2 problems.
Get x by itself.
Correct. We want to get x by itself, so we need to make a what pair?
0.
Yeah, we're going to make a 0 pair. So first thing we're going to do is we're going to make that 0 pair by subtracting by 15. What's 4 minus 15?
11.
Good. And it will be negative 11 because the negative 15 is further from 0 than 4. So we keep the sign of the number with the greater absolute value. And then how would we solve?
Divide.
That's right. We're going to divide by 2.5. So what is x going to be? Is it going to be positive or negative?
Negative.
It is going to be negative. And what's 11 divided by 2.5?
4.4.
That's right, 4.4. I'm going to leave this up here because I really want y'all writing down how to solve these problems. Because if you don't write down how to solve them, Are you going to be able to do it tomorrow? Probably not, unless you just know how to do it right now by yourself. All right.
Can I get a pencil?
Yeah, hurry up. You got it. Lainey, I want you to read number 9.
Mary has $50 to spend on t-shirts from her online store. There is $10 shipping and handling fee, and each shirt costs $5. Which inequality represents the number of shirts Mary can buy?
All right. So, how much money does she have to spend on the shirts?
$50.
All right, we got 50 to spend on the t-shirts. There's a $10 shipping and handling fee. Each shirt costs $5. And it says it wants the number of shirts to be represented by S. So who can come up with an inequality for this? Would we want it to be less than or equal to 50 or greater than or equal to 50?
Less than or equal to.
Why?
Because she only has $50 to spend.
Correct. All right, so that means we're getting rid of that one. Okay. So each shirt costs how much? $5. Do we know how many shirts she's going to get? No. So how can I represent $5 times the amount of shirts that she gets?
5 times S.
Correct. All right, and then it says there's a $10 shipping and handling fee on top of the 5 times the number of shirts. So would you subtract or add that?
Add.
That's right. So which one's looking like this? B. Good. Anybody got a question? Okay. Let's go to number 10. All right, so this one says that it wants us to answer it in the nearest tenth. So since this is 2/5 right here, and it wants us to answer in decimal form, what could we go ahead and do to 2/5? Could we change 2/5 to a decimal? How could we do that?
Divide.
Yeah, you just divide. You see how many times 5 goes into 2? And it's 0 point what? How many times does 5 go into 20?
4.
There we go. So we get 0.4. So we're just going to rewrite this as negative 3x plus 2 equals 0.4. All right, so when we do this, what's the first thing we need to do so that we get negative 3x by itself?
Subtract.
That's right, we're going to subtract first. All right, so when we subtract, we got minus 2. It's going to make a 0 pair. We subtract by 2 here. So we're going to be left with negative 3x is equal to negative what?
1.6.
Perfect. Now what do I do to solve?
Divide.
All right, so we divide by negative 3. And when we do that, we're going to get x is equal to 0 point what?
53.
Correct. And that 3 just keeps going, doesn't it?
Yes.
All right. Now, it says round to the nearest 10th. Well, that's the 10th place. So if I'm rounding to the 10th place, is this 3, 5, or more?
No.
No. So what does that mean happens to the 10th place?
It's staying the same.
Correct. So what should x be equal to?
5. No, 0.5.
0.5, or you could say 5 tenths. Good. All right, looking at the next question. Solve for x, enter your answer as a decimal rounded to the nearest tenth. So that's basically like the same thing we just did, right? Yes or no?
Yes.
Yes.
All right, so let's see if we can do it. We got 5 times x minus 1 equals negative 3. All right, so looking at this, Layla, what do you think we could do?
That problem confused me.
That's okay. So what property do we have to do to multiply this 5 times the x and that negative 1? Does anybody remember? Starts with a D.
Distributive.
The distributive property. So we do 5 times x, and we get 5x. And we do 5 times negative 1, and we get negative what?
5.
Correct. And so this is equal to negative 3. And once again, we need to get 5x alone. So what do we need to do to that negative 5?
Add 5.
Correct. We're going to add 5 and make a 0 pair. And so we're left with 5x equals, what's 5 minus 3?
2.
2.
2.
And so to solve, what are we going to do, Sarah?
Divide.
You're right. We're going to divide by 5. And so we're left with x equals 2/5. But it says enter our answer as a decimal. So what am I going to have to do?
Divide.
Yeah, we're going to divide. And we've already done this right here. We know that 5 goes into 2 how many times?
4.
4 tenths, right? Or 0.4. All right. Does anybody got a question about that problem? Or any of the other ones that we've done so far? All right. So we're on number 12. Read that one for us, Najela.
A waitress earns $20 per day plus $3 for every table she waits on. She has a goal to earn at least $50 a day. Let S represent the number of tables she waits on by the waitress. Which of the following are true about the scenario? Select all that apply.
All right, so how much do they earn per day?
$20.
$20. And then how much do they get for every table they wait on?
3.
Okay. And how much is her goal to earn?
50.
All right, and it says at least 50, right? So what does that mean if we're thinking about an inequality?
Greater than or equal to.
Correct, because she wants to make that amount or more. All right. And so it says let S represent the number of tables. So we know she earns $20 plus what?
$3 per table.
$3 per table. How do I show that? Do we know how many tables she waits on?
No.
No.
So you use X.
Correct. And in this case, they want us to use S. And we said that we want it to be greater than or equal to 50. So let's see if we can find some answers that look similar to what we got. So looking at A through D, it says the waitress must wait on 10 or more tables, or the waitress must wait on 8 or more tables. How would we figure out how many tables she needs to wait?
3 times 10 plus 20.
That works perfect. So all we're doing is subtracting by 20. We make a zero pair. We're left with 3s is greater than or equal to 30. We divide by 3. And so we're left with s is greater than or equal to 10, just like Emma said. So A works. And then out of C and D, which one would we use?
C,
C. Why?
because it's greater than or equal to 50.
Correct. Because we want our money to be greater than or equal to 50, not less than 50. Does anybody have a question about that one? All right, let's look at 13. It says fill in the blanks to make each expression equivalent to the expression 64p minus 32 divided by 8. So this has division, but we know there's another way to write division so that we can multiply by this 64p minus 32. So what could I do so that I can multiply? Like, what can I multiply that would be the same as dividing by 8? I want you to think of fractions. If I have 4 and I divide it by 2, that's going to give me 2. If I have 4 and I multiply it by 1/2, what does that give me? What is half of 4? 2. So dividing by 8 would be the same thing as multiplying by what?
1/2.
Close. Not 1/2, but 1.
4.
Look at that number.
8.
That's right. It would be 1/8. So we would write this as 1/8 times the quantity 64p minus 32. And so what property do you have to use so that you can multiply 1/8 by both of these numbers?
Distributive.
So that's what we're going to do. We're going to write 1/8 times 64p plus 1/8 times negative 32. So what is 1/8 of 64p, or 64p divided by 8? Correct. We get 8. And what is negative 32 divided by 8, or negative 32 times 1/8?
4.
It would be 4. Would it be negative or positive?
Negative.
Negative. Great. All right, we got 2 left. So it says fill in the blanks to write an expression equivalent to the expression 2/5 times the quantity x minus 3y minus 3/4 times x minus 1/2 y. So it says fill in the blanks to write that expression equivalent to that. So what could you do? What would you add to this so that it's the same? Because isn't this the same as this?
Yes.
That's the same. So if you're writing an equivalent expression and this says plus, what's the only thing that we could add to it to keep it the same?
The opposite.
Well, that would make it 0, but it says write an expression equivalent to the expression. They're exactly the same, aren't they?
Yes.
Well, if they're exactly the same, what's the only thing that we could add to it to keep it the same?
The same thing.
Well, if I add the same thing to it again, that's going to make it a bigger number. What can I add to something and it be itself still?
0.
Yeah. So those two would have to be 0. Right? We made it too hard, didn't we? Good job, Roy Kia. You got it going. All right. We got kind of like 3 questions left, but we can knock them out quick. To Chandra, tell me how to solve A. What would I do?
First, I set up the thing negative 1.5 x plus 2 equals 6. Then I did 1.5 x plus 2 minus 2 equals 6.2. You're supposed to add 2 for each one.
All right, so we subtract 2 here. We subtract 2 here, so we got negative 1/2 x equals 4. And then what would you do?
Divide 1.5.
Correct.
Divide by 1.5 equals 4 divided by negative 1.5.
Good. And what would x equal?
X equals negative 2.66667.
All right. And so let's just round to the nearest 10th. So what would we do? 0.66 would round to what in the nearest 10th?
2.7.
Good. All right, let's try the next one. What would I have to do with negative 1.5? Wouldn't I have to multiply it by both of these numbers? Here and here? Using the distributive property? What's negative 1/2 times x?
Negative 1/2.
Good. And what's negative 1.5 times 2? Wouldn't that be negative 3? Is that negative 3? 1.5 plus 1.5 is what? Isn't that 3?
Yes.
All right. And then so we need to get negative 1/2 x by itself. So what I need to do with this minus 3?
Add 3.
Good. So that makes a what pair?
0.
Good. And so I'm left with negative 1/2 x equals 9. How do I solve?
Divide by 1.5.
All right. So what is 9 divided by negative 1.5?
Negative 6.
Perfect. All right, now we got one left. What's different about it? The what?
Parentheses.
Yeah, the sign's different on the inside. Still going to be the same though. So we got negative 1/2 x. Negative times a negative is a?
Positive. Positive.
Good. So how do I get negative 1/2 x by itself?
You add 1/2. No.
To get negative 1/2 x by itself? What do we always make first? A what pair?
0 pair.
So what do I need to add to 3 to make it a 0?
-3.
There we go.
-3.
Good. What's 6 minus 3?
3.
3.
Good. And what am I going to do to solve to see what x is?
Divide.
And so what would that be? What's x going to be? Is it going to be positive or negative?
Negative.
Negative. And what's 3 divided by negative 1/2?
2.
Good.
-2.
Perfect. All right. We have completed our study guide.